Space looks peaceful from Earth. A black sky, tiny stars, beautiful galaxies. But that view is hiding something. Because scattered across the universe are places where matter is crushed beyond imagination, where radiation can tear through living cells, where gravity can bend time, and where entire planets can disappear without leaving a trace. And the terrifying part? You don't need to travel to another universe to find them. They're already out there, waiting.
Our first destination is perhaps the most famous nightmare in the cosmos, a black hole. But a black hole isn't simply a giant hole floating through space. It's a region where gravity has become so extreme that once something crosses the event horizon, there is no known path back out, not even light. And that creates a disturbing boundary. From far away, you might watch an object falling toward a black hole. But as it approaches the event horizon, the black hole's gravity dramatically distorts the light coming from it. The object seems to slow. Its image becomes increasingly distorted, and eventually, it disappears from our view. The universe hasn't necessarily destroyed the object in that instant. It has simply placed it somewhere from which information can no longer reach us.
But black holes aren't the only cosmic monsters. Some stars die in a completely different way. They collapse into objects called neutron stars, and the most extreme examples are known as magnetars. Imagine taking more mass than our sun and compressing it into an object roughly the size of a city. Now give that object an extraordinarily powerful magnetic field. The result is one of the most violent environments known to physics. A magnetar can suddenly release enormous bursts of high-energy radiation, and its surface isn't anything like Earth. There are no oceans, no atmosphere you could breathe, no familiar landscape. Just an ultra-dense stellar remnant, surrounded by extreme magnetic and radiation fields. A place where ordinary matter behaves in ways that are almost impossible to imagine.
Now imagine something even stranger. A planet with no star. Rogue planets are worlds that travel through interstellar space without being gravitationally bound to a star. Some may have been thrown out of their original planetary systems. Others may have formed in ways we still don't completely understand. Imagine standing on one. Above you, there would be no familiar sunrise, no warm yellow sun, no bright daytime sky, just an almost permanent darkness. The surface could be unimaginably cold. And yet, some rogue planets may potentially retain internal heat beneath their frozen surfaces. Entire worlds, wandering through the darkness, with no star to call home.
And then there are neutron stars. They are among the densest objects in the universe. A teaspoon of neutron star material would have an almost incomprehensible mass. Their gravity is so powerful that standing on the surface would be completely unlike standing on Earth. You wouldn't simply feel heavier. The difference would be catastrophic. And the star itself is rotating incredibly fast. Some neutron stars spin hundreds of times every second. Imagine looking up and seeing beams of radiation sweeping through space like a cosmic lighthouse. Every rotation, again, and again, and again. A world that looks tiny from a distance, but contains more extreme physics than almost anything we can encounter.
But sometimes the danger isn't a place, it's an event. A massive star can reach the end of its life in an explosion powerful enough to briefly outshine an entire galaxy. A supernova. For a planet unfortunate enough to be nearby, the consequences could be devastating. Intense radiation, a shockwave moving through surrounding space, and enormous amounts of stellar material launched outward at incredible speeds. The star that once provided light becomes the source of destruction. And the explosion doesn't end when the flash disappears. Its debris can continue expanding for thousands of years, turning the remains of a dead star into a gigantic cosmic graveyard. But perhaps the strangest, terrifying place isn't filled with radiation. It contains almost nothing. The universe has enormous regions known as cosmic voids. They're not perfectly empty, but compared with the dense regions surrounding them, they contain remarkably few galaxies. Imagine traveling through one. For millions of light years, there might be almost nothing ahead. No planets, no nearby stars, almost no galaxies. Just darkness. And this creates a strange realization. We usually think emptiness means safety, but in deep space, emptiness means isolation. There is nothing nearby to guide you, nothing nearby to rescue you, and almost nowhere to go. And now we reach something even more disturbing. Near an extreme gravitational field, time itself can behave differently. According to Einstein's theory of relativity, gravity affects the passage of time. The stronger the gravitational field, the greater the difference can become between clocks in different locations. Near a black hole, this effect can become extreme. That means a short period of time experienced by someone near a black hole could correspond to a much longer period for someone far away. So imagine returning to Earth after what felt like minutes, only to discover that years had passed for everyone else. You haven't traveled through time. You simply experienced it differently. But here's the twist. The most terrifying places in the universe aren't necessarily the biggest. They aren't always the brightest, and they aren't always the most violent. Sometimes, the most terrifying thing is scale. Every star you've ever seen in the night sky is just one object among hundreds of billions in our galaxy. And our galaxy is only one among countless galaxies. Black holes, neutron stars, rogue planets, cosmic voids, supernova. They're not separate universes. They're pieces of the same universe we already live in. The terrifying part isn't that these places exist. It's that the universe is so enormous, we've only begun to discover what's actually out there. And somewhere, right now, a telescope is looking deeper into that darkness, finding something we have never seen before, something that could completely change what we think we know about the universe. Because space isn't empty, it's hiding things. And the deeper we look, the stranger it gets.